Welcome to another fun video of geometry. So we are looking at geometry axioms, and here are they. There are 6 of them, and they may seem very obvious to you. So let's look at the first one. The whole is the sum of its parts. So here we have a whole angle. Notice that the big angle is called angle EMO, right? And that angle breaks down into 2 other angles that I can add, right? So that would break down into angle MOP and angle PME. So this is an example of the whole is the sum of its parts. Okay, that's an example. Now, the subtraction axioms, you've seen this before, means that I can subtract any angle from this side, from the left, from the right side, and these two will still be equal. So I can subtract angle PME to both sides. All right, I can subtract that from both sides. This side will cancel, and I will end up with angle EMO minus angle PME equals angle MOP. That's it, okay? That's the subtraction axiom. The addition axiom does the same thing. It means that I can add this angle on both sides and they will still be equal, okay? See, I still have the equality symbol. They're still going to be equal. That's all it says. And you've done that before when you subtract and add numbers on either side. Okay, now let's look at the other axiom. So we are up to the substitution axiom, number 4. That one tells us that if I have this case where I know that one of the angle measures is 35, for example, I can substitute that. I can say that instead of writing MOP, I can say this whole thing is 35 plus angle PME equals angle EMO. That's all that says, okay? Substitution. And we're up to number 5. The whole is greater than any of its parts. Well, that makes sense. This entire angle has to be bigger than any of these 2 angles, okay? That's all that says. And lastly, the reflexive property. This one is the really well, that makes sense, right? This is all that's saying that angle EMO is equal to angle EMO. Yes, it cannot be equal to anything else. We know that. All it says is that any geometric shape or geometric measure is equal to itself. All that means, okay? Any shape is equal to itself, and any measure is also equal to itself. So 5 is equal to 5. A is equal to A. That's an example, okay? Let's look at a few examples here. So let's apply these axioms, okay? I have my given, I have what I have to prove, and then you can test this out on your own if you don't believe it. You can test this out. So the first statement is that I have angle BAD is equal to angle CAE. Well, that was given to me up here. So my reason for that is that that's given. I need to prove that the measure of BAC equals the measure of DAE. And I've filled these statements out for you. So the second part was that we broke angle BAD. Angle BAD, here's angle BAD. And I broke it into its component parts, into BAC plus CAD, okay? I broke that down, and all that's saying is the whole is the sum of its parts. That's the same thing that I did to CAE. So the whole is the sum of its parts, okay? And now for the bottom one here, notice I have CAD on both sides. Well, what do I know about CAE? This is the obvious one. Well, duh. This is true, isn't it? And we call that the reflexive property. Well, since now these two sides are equal, what can I do to both sides? I can subtract CAD from both sides, right? Can subtract CAD from both sides and they cross out. So left with BAC equals DAE. And here it is, okay? And the reason why I can do that is because I subtracted. And that's called a subtraction axiom. You may also write just subtraction, okay? Notice I started with the given and I ended up with what I wanted to prove. That's the structure you'll always take. Okay, so now we've already learned a lot, and one of the things that we learned was that vertical angles were equal, right? 1 is equal to 3, 2 is equal to x, let's say, right? Vertical angles are congruent. So let's start off with what is given to us. So all I did was just rewrite the givens. Okay, now let's see what else can I get from this information. Well, from here, I know that angle 1 and angle 2, those are supplementary. They add up to 180. I know that for sure. And there it is, right? The measure of angle 1 plus the measure of angle 2 is 180. And we know that the measure of angle 2 plus the measure of angle 3 equals 180. And that's simply because angles on a line are supplementary, right? Angles on a line add up to 180. What else do we know about this diagram? Well, now that I have this equation here, right, both of these angles added up give me 180. So I'm going to go ahead here and make a substitution. And there it is. There is my substitution. The measure of angle 1 plus the measure of angle 2 is 180. But so is the measure of angle 2 and the measure of angle 3. So instead of writing the 180, I simply substituted. And I can do that because of the substitution axiom. Take some time to process that now. I know that may be a little complicated to understand, but try, and then ask a question in class tomorrow if you still don't get it. And here is the big duh, right? I have measure of angle 2 on both sides. So boom, I know that I can say that the reflexive property says that those two angles are going to be the same, right? They're going to be the same. They're equal to each other. There it is. Now, what can I do because those two angles are equal to each other? Yes, I can subtract them, right? So I'm going to subtract them. And there it is. I've subtracted the measure of angle 2 from both sides. Right? And so they end up canceling out, leaving me with the measure of angle 1 equals the measure of angle 3 by the subtraction property. Okay? And hey, is it true that I proved what I wanted to prove? Yes, I proved that vertical angles are equal. Angle 1 and angle 2 are vertical. Yes? So I could do the same exact proof if, say, I had here a 4, I could prove that measure of angle 2 is also equal to the measure of angle 4. So here is your CFU. And all I'm asking you to do is to first make the test, right? Do you believe the proof? Do you believe that CB is equal to FD? Okay? And here are 3 reasons for these 3 statements, just like we did in the previous proof where I had 5 statements and 5 reasons. You are now going to have 3 statements and 3 reasons. I'll see you in class tomorrow. Enjoy.